Good day. We are going to be working on another area formula for the area of a triangle called Heron's formula. All right. Now, your text reading really goes through the derivation of this formula. It takes about 3 pages to do it, and in the reading. And I encourage you to read through this derivation. And the reason is I want you to see that every algebra trick in the book is used. There's renaming of variables, there's introducing new variables, factoring distributive properties, collecting like terms. Every algebra thing you know exists in this derivation. Now, if I do that derivation here in this video, it will make the video too long, so I'm not going to do it. But I want you to do it. And you can do it. You just need to sit down and read the mathematics and listen, in some sense, to what they're describing in terms of how you do it. And Heron's formula is a formula used for side-side-side triangles. Now, yesterday, I did the side-side-side by using the law of cosines, where I would use the law of cosines to find one angle, and then once we found that angle, we could find the height, and then from there, we could find the height by making a right triangle, and from there, once we had the height, we already would have a base, and we could then find the area. So I actually like a law of cosines approach to side-side-side because it's so similar to the other things that we did yesterday. Now, yesterday, I really emphasized that just doing the geometry of the situation makes more sense. In Heron's formula, the geometry leads to really an algebraic nightmare. It's not near as straightforward as the law of cosines method I did yesterday, or the other two methods we looked at, the one using law of sines and the one where you can just use a right triangle on side angle side. So I see Heron's formula as one of those formulas that I would just know, because its derivation is tedious, and it does have lots of variable substitutions. So it's worth it for you to look at it, see how it's done, and go, wow, that's really clever, because it leads to a really interesting formula. Area is equal to the square root of s times s minus a, s minus b, times s minus c. And A, B, and C are the sides of the triangle. And S is called the semi-perimeter. It's basically the perimeter divided by 2. So it's A plus B plus C all divided by 2. And that is what the semi-perimeter is equal to. So this becomes a very easy formula to use to find area. Let's look at a problem. So it turns out I didn't record this, but I wrote it all down. So let me do that. As I said before, Heron's formula is used in the case where you know all 3 sides. It's actually very easy to solve. You find the semi-perimeter, which means you add up all of the sides and divide it by 2. So I get 21 halves for that. Then you put it in the Heron's formula, which is area equals the square root of semi-perimeter times semi-perimeter minus one side, semi-perimeter minus the second side, semi-perimeter minus the third side. Once you fill those things in, which I have done here, all right, then you can go through, and these are pretty simple, and then I just do the arithmetic, and then what I noticed is 21 is 7 times 3, so 7 times 7 is a perfect square, so I wrote 49 times 3 times 13, because that's what's left over, and I get 16 on the bottom. And then I simplify, square root of 49/16 is 7 over 4, and then I have the square root of 39. So this is the answer here. But this only really works because these were pretty simple side measurements. You know, what if the side measurements were 4.17, 7.96, and 10.37? Well, then your semi-perimeter is going to be a much nastier number in terms of decimals or whatever. And so I would tend to do this on a calculator. And to do that, I'll just show you. Let's go ahead and fire up a Desmos calculator here. And we're going to do that. Now, to do that, I would put the square root. I would put the semi-perimeter. And if it's a simple, not a repeating decimal or anything, you know, if it was 10/3, I'd put 10/3. But in this case, it's 10.5. All right? And then I'm going to multiply that times the semi-perimeter minus A, which was 4. And then the semi-perimeter, minus 7. And then the semi-perimeter minus 10, which are the three sides. So I would just enter it in the calculator that way, and as you can see, we get the answer 10.92. Now the answer we got earlier, 7 times the square root of 39, all divided by 4. Turns out that's equal to exactly the same thing. So sometimes you can simplify them exactly. Most of the time with Heron's formula, it's good just to pop it in a calculator and get the solution. Okay? And so that's essentially all I want to do for this particular problem. We've got it all. Alrighty? Good luck. Have a good chance doing the assignment. We'll talk to you later. Bye. So it turns out I didn't record a video for this part. So as I said, what I want you to do, make sure you look at the derivation, okay? We may talk about this a little bit in class next week, but make sure you look at it and see if you can kind of catch some of the tricks. There will be some algebraic things I want to show you from this derivation. Make sure you do the practice, okay? You want to practice this so you know how to find semi-perimeter and use it in each situation. Also, next week, because TELPAS is occurring, check your CC schedule. You will not have conflicts, but make sure when you are scheduled for pre-calculus that you come. Now, we might have 100 students show up to that, but that'll be okay. We'll do class like we normally do. We might have a little extra time so we can really answer some questions and do some things like that. So I'll be looking forward to you guys coming next week. Finally, if you are behind and you want to catch up, see me about a plan if you need a plan. And also plan on using spring break which is a couple of weeks from now, as a time you can catch up. You have 9 days where you get no new assignments. So this is a perfect time to get all caught up. And then when you come back in March and April, you can work towards earning exemption. So I'm gonna fire up the Unit 2 test so that you can start to do retakes on that. All right. And I'll be grading the midterm and grading corrections on the midterm as you turn them in. Remember, the midterm locks at the end of spring break. In other words, I want everybody caught up through at least the midterm by that day, March 19th. Okay? All righty. Once I lock it, I'm not going to open it again. Okay? So you'll get what you get based on not taking the midterm, and I do not suggest that. Corrections can still be turned in for the midterm, just not the actual midterm. Okay? So keep that in mind, and we'll see you next week.